Hello, welcome back to the stream. I am Jun-chan, and today we're back doing some Haskell. But I decided to, change a bit the structure. As you know, everything might change without notice. So no notice, and today, April 6th, until, I suppose, April 13th, would that be right? 12. We shall be doing Haskell, data structures. So we'll add this to our workbench, and this is the intention here. Knowledge management. These logs are great, but what's better? And one thing that's better is Zettelkasten, for instance, as a way that academics are encouraged to keep track of some of the things they're learning, the domains they're investigating, and that's been popular in the kind of productivity software scene. One of the software is written in Haskell, and it's termed to be based on Zettelkasten and has this nice clean UI. And I really wanted to sort of start with that. One of the things that I really like is this ability to keep the context available up there as a sort of where you're coming from, sort of, and also keep track of backlinks and uplinks. And seeing this in application, for instance, maybe we'll see some examples somewhere. Let's see. Installing examples. This is the very site, the author's notes in microblog. Right, so here you see there's tags and sort of context at the top. What is zoomed in here, and then some backlinks. The backlinks can include also context and where. I think there's an example of that elsewhere. Maybe it was this. Maybe not. Here, yeah. Uplinks can include the actual context of where the particular idea this is in Zettelkasten parlance, I think this would be a card. So this is a neat system. It's obviously an improvement over, the kind of linear tracking I'm doing. You see that this linear tracking actually has an attempt to sort of fork into categories with the different logs there. But especially when I get to sort of let's say things where learning is the most important feature, or even maybe organizing my own mind about where things fit and what I want to pick as a sort of next subject of investigation, with the ability to kind of leave things where I left them. Go back to things and continue where I left them in a way that will be easier to navigate than this linear list. So obviously having some kind of tagging system, something that allows to actually refer back to the contexts, including a parent's context or multiple contexts that a particular note or idea linked to, is really useful, as well as more full linking of where these things appear elsewhere. And so building more of the kind of cross connective tissue beyond and between, like tree leaves and so on. And in fact, Zettelkasten examples that point at the original paper version explained that basically one of the main idea was the indexing and the ordering, with the idea that the indexing and ordering, which is in this way, sort of allowed to have branching in a way that worked well with paper, because you could continue idea one by just taking a new note of paper, calling it 1A, and then attaching it to, or let's say inject it conceptually at least, but maybe even like put it in an order. And so you know then when you bumped into 2 again, that would be the content of that branch of thinking, of thought. And so this is nice. And I think this indexing, actually, this type of trees, actually, I think correspond to an intuition I have that I want to test out in UIs and whatnot. But before I test them out in UI, I want to also think about an efficient in-memory and on-disk representation for it, because I'm thinking about abusing those to even maybe at a later point to sort of build graphs with it, where I could maybe connect 1B to 2 and be able to traverse those also really easily. So backlinks and crosslinks. And if I talk about this, I should talk about something that I've checked out, which is this idea of a structured graph in the parametric higher order abstract syntax way, which is a mouthful. I don't know if the idea will be represented here. Yeah, I think I saw the video presentation from ICFP. This one, functional programming with structured graphs. And let's see if we can find some good slides to stop on, for me to comment on. I think, well, some of the things that are sort of seducing me just right from the get-go, this idea that oh, okay, I've moved around. Well, this idea that you can represent cycles in a way that mean that you you can traverse the graph in a way that will correctly take advantage of the cycles, but you can represent your cycle in the smallest amount of memory necessary for that. And in fact, you can even define traversals that will respect the structure of the cycles without needing to go into infinite loops. So okay, I think I have some issues with my either the browser or my computer. That's seems to be kind of halting and getting freezing once in a while. Okay, anyway, this I won't get into at all today, but it is kind of interesting because it's because I see a graph structure in here in this, and it would be good to take advantage of that. So okay, so the thing is though that this neuron tool, although I really like the UI, it's written in Haskell, which means that we could build a extension from it. But as far as I could tell, and it has a VS Code extension, a partner extension with it. But as far as I can tell, it doesn't really use this kind of branching model. It's kind of up to you whether your hierarchy is going to, or what it's going to look like. Everything is kind of a flat document at the root, and then it's the linking between the document and the tagging that determine the structure. But you kind of lose this idea of like, oh, I come back to this idea and I add to it. In fact, if you squint, you see that something like this is exactly this structure. I add this and then I start writing into it as a new context. And so it means that I'm actually interested at using this structure both at an intra-document level as well as a cross-document level. In fact, ideally, I'd want this to be, in some sense, scale independent, so that we don't have documents, or documents are an arbitrary way to capture some root and a certain amount of leaves. So it means that potentially this whole directory would be just one document in some sense. So hence my interest in data structures that scale well. And in this realm, I think the really inspiring work that's been done in the Haskell world is by Edward Kmet. When a few years ago, he took him upon himself to see that there were these really advanced data structures that were well known in computer science, used quite a bit and having implementations in other languages, but not so much in Haskell, which is not necessarily so surprising because they care about like low-level optimization of data structure. But the gains that they obtain can be, like things like 10x speedups or more, which is the type of stuff that Ed is often interested in. And so he did this work on something called cache oblivious data structures, and after that on succinct data structures. And those provide different benefits. And we're not going to go deeply into how they work because I only have a shallow understanding of how they work. And even though there is a need for a more let's say accessible introduction to this data structure than the one that Ed has provided so far, you could argue that it's also pretty good, and so you could go definitely check out the existing work on that, which I suppose I should link to. But for that, I need to do a few things that I should have done before, which is to update the log to today. And then, I want to pick up something that I've been working on in the in my other logging for when I'm not streaming, and say data structures, or maybe knowledge management. I think that's the better title for it. And well, I don't know if I'm ready to share this, but we shall see. And I'll put some links in. So YouTube and Kmet and succinct. That's actually probably the best one for this particular topic. We need to open it to have the proper link without the goddamn tracking. But there's a few. Plus there's some live coding on Twitch. And then there's the cache oblivious work. Maybe it's the browser. Yeah, probably is. Oopsie. cache oblivious maps. And I need to do the same thing. Actually, I think I watched the jam, but this one is 1 hour 25. The Haskell Bay Area has Haskell group, so that's probably going to be a more thorough one. So I've actually stopped doing this links thing. It's because I've shifted to Firefox, but maybe I should go back to Chrome here and use some of the tab capture stuff that I was using. Okay, so in this work, right, I need to copy this here. In this work, so there's two things, right? Cache oblivious data structures are data structures that are optimized to deal with multiple levels of cache. Level 1, level 2, level 3 in modern CPUs, plus memory, and then maybe even sort of on disk. And then even maybe the disk that's in your disk hardware. The idea with the cache oblivious data structure is that it's a data structure that doesn't need to be tuned specifically to any given cache, but that by picking a choice of trying to be tuned for sort of an unknown size of cache ends up to be really good for all your cache levels. And the way that you do that is by basically building sort of skewed data structure that can are not distributed symmetrically, but instead are distributed in a kind of a wonky, skewed way, so that the cache end up overall filling cache lines with relevant data over time, the things that you regularly access. So, so he, based on that, built a data.map that was apparently 10 times faster, 7 to 10 times faster for lookup. And he also mentioned that range queries were really fast. But and he published this in IncMat, or is it? Yeah, it is IncMat, in Structures, which has been unmaintained for 6 years. And there were some benchmarks and whatnot. I couldn't run this code, but that's because I tried it on my Mac machine where I had a pin GHC. So I want to try this, maybe adding some mix and compiling it with whatever the world was like back in 6 years ago, and then try and take a look at it. But the thing is that there is follow-up work that's been done on this by the Haskell Works GitHub organization, which is a GitHub org that's managed mainly by two folks Sydney-based, but apparently John Kai has been quite busy with IOHK work, so I'm unsure. I've started evaluating these things, and I think that one of the most up to date is this one. But again, on my Mac, I had some trouble compiling, so I want to go back to this now on stream and continue from where I left off and try and see whether I can, give a shot at this. And I don't want to use. I want to be just a user of these cache oblivious data structures. I don't want to build new ones yet if I really don't have to. Though I couldn't help but see that there are cache oblivious maps this cache oblivious JSON and XML. Hold on, these are succinct. Those are, yeah, those are succinct. Those aren't cache oblivious. So I think actually the cache oblivious work, it kind of maybe got stuck there. I'm not completely sure where it's gone. That's one interrogation I have, and I should definitely ask Ed, to be honest. And maybe I should ask this in an issue. I know of the Haskell works REPL with succinct data structures, but can't tell at first glance whether it also includes cache oblivious data structures. Okay. All right. So that's one thing, right? And I do want to poke at it. And what was implemented here was a map. And it could be that a map is really what you can. I mean, it seems like you can get a set. I wonder if you could get a tree. Probably you can. Or maybe you need. Also, I think his implementation had no delete, only inserts, but that would work for me mostly. I think because I might. Well, yeah. Fast inserts was one of the main aspects that he had, which was the problem, I think, with the naive implementation that would be array-based. But deletions, well, we need to think about deletions. But maybe we can take a quick look at cache oblivious trees. So B trees, I think that ended up being as fast or faster than a B tree, I think. But I don't think it uses a B tree underneath. Yeah, there's prefetching. Yeah, prefetching primitives. That was pretty advanced. Is that the main data structure right there? LA, I think it is. So it's like this weird numbering system where I think this is the more complicated one. Let's see if ephemeral is slightly simpler. It is, but that one is, I think, way too simple. Yeah, I think so. I think he improved on this, but like this is, yeah, this is something else. This is for fusion. Right. So I think the idea here is that you hold, I think this is different than his presentation, but you hold, I don't know, maybe, right. You hold an array of key and an array of value, okay. And either you have nothing, or you have one thing that has an array of key and an array of values, or you have something where you have two arrays of keys and values, and a thunk that will be merged later. And then you do the same trick the level above. Except now I think you have the fresh array that you're adding to directly, the two ones that are pending that you're waiting to be merged, and then the thunk for when you're going to merge them. And the whole point of doing this is to get the right asymptotics in a lazy persistent setting, where you'll be able to decide when you pay the cost of the thunk, and that you also make sure that in the persistent setting, if two copies of the same data grow, and that they therefore require to go to the next constructor in the binary or in the numbering system that is the basis for this construction, then you won't pay the price twice in each of these worlds, because you'll be able to just put the thunk, evaluate it only once, and then the other one will be able to reuse the result. So that's the smart way to do. That apparently comes from Okazaki and his book on fast persistent data structures. So that's kind of cache oblivious, and so and the numbering system and this kind of the 1, 2, 3, and then the counting system that comes from it is the way that to get things to line up nicely in cache for any size of cache. And apparently this leads to asymptotics with square roots of n and logs of n and whatnot. So yeah, and this thing apparently is called a COLA, or cache oblivious look ahead array. And so let's see. So by the way, as I understand it, the way in which this is relevant for software engineering at large is that this improves on the this is equal to B trees, and it can be made even faster with this idea of fractional cascading. And so it makes a Haskell map as fast as a search in a database, basically. And so you kind of want that. But so the B trees are going to pop up, but it's going to mean that it's hard to find maybe cache oblivious actual trees, because B trees are usually used just for the indexing aspect of things, which make the matching of an index and a tree path sort of the way that you do lookup or search inside your data structure. But that's not what we want. So let's see if I can do cache oblivious map and data structures, and maybe hope that we find a repo in, for instance, GitHub that has cache oblivious data structures and including a map, and then maybe some other ones. So this has a few things like a B tree and AVR tree, display tree. I'm not good at those things, by the way, at data structure. I haven't done computer science, and so I haven't even learned it, forgotten it. I never really learned it. Streaming B tree, I presume. No, yeah, streaming B tree. That might be relevant. And Bender is, I think, one of the guys. So this might be online, and I kind of want online in my for my sort of Zettelkasten shaped problem. Meaning I want the index to still have good performance as I keep adding stuff to it. I shouldn't have to reconstruct an index by scanning it each time statically. It needs to be rebuilt automatically, which is what Ed's data structure has. Range queries. The caller implements searches in O log n transfers. Range queries in O log n plus L. So I think that's the depth of the tree and I don't know what. And insertion is O log n / p transfer. This might be the paper. It might be the one that it wasn't called streaming B trees though. In what was the year for this? 2007. Yeah, no, it might be later work, but it might be built on that. Let's take a quick look at the slides. Yeah, I think that's a set of slides. And so here, apparently, there's also an attempt to do both cache oblivious and succinct, by the way. So it could be that, in fact, in Haskell Works, they have included it. So maybe I should have thought a bit more about this before posting to YouTube, but hey, maybe others will ask themselves that. So yeah, so that's simultaneously optimizing for different levels of cache, and the data.map that is optimized for a memory model that doesn't exist, and then offsetting to avoid destroying your set associative cache, and then make the structure updatable. And the Bentley Sachs is, I think, give us a numbering system, and then Ed goes about and uses his Okazaki superpowers to make this work with this weird numbering system. And then it makes a thing that's faster, and it could be even improved. And as far as I know, these improvements have not been implemented. And then he points at succinct data structure right there, which I suppose, the way that I understand this so far is that they require building an index for an existing data structure. But I think it's an index that you can, well, I don't know whether it's an index that you can incrementally update or not, like the cache oblivious data structure. But I think those rank 9 poppy are implemented in the succinct thing, and I haven't talked about succinct yet, but that's the part that I know less, to be honest. And then, oh, succinct trees. Parse data takes several times more space than the raw format. Oh no, but that's succinct trees. Yeah, succinct trees, that's easy to find literature about. But cache oblivious trees, I don't know. And maybe, yeah, so when I was saying that we wouldn't build any cache oblivious data structure, I don't know yet. First, I want to use them, kick the tires. Then I want to find out whether do I need to build some, like for trees and so on, and maybe graphs, because there's more recent work that's done on succinct graphs, for instance, and online dynamic graphs. Okay, so yeah, that's what I want to find out. So before I figure out whether I need to build some, then I want to familiarize myself with them by just at least being able to use them. That means, building the library, poking at it, looking a little bit at the implementation, looking at the examples, trying to use one, and then thinking about whether my Zettelkasten tree problem indeed can be fit into some of the existing tooling we find when we try to use them, or whether we need to build some new stuff. So that's kind of where I'm at. And then some of the stuff that I've looked at is pretty much what I just told you, I think. I think I look at other things like GTK3 Markdown not taking application, because I was wondering about Markdown syntax inside GTK, because we're doing GTK elsewhere, right? Or at least GI. So I was looking a little bit at that, because it seems like we'll have a Markdown parsing question on our hands. So some of the usage that I want to check is, well, basically, as I said, install and try the examples of libraries, existing libraries, and that means, that means structures, HWJSON, and maybe a few other things. And then kicking the tires means think about parsing JSON, parsing Markdown, not JSON. And that's going to be another interesting way to, and maybe, maybe we want to adapt Markdown so that it's easier to parse for our purpose, because I don't use the whole set of Markdown, but I get used to using certain things, and yeah, so. But we might also need extensions for it, for structured data and whatnot. So that's one thing. And then, of course, I want to also think about how to plug this into a editor or a REPL or a shell or whatever, something that looks like an IDE or maybe a knowledge integration development environment. And so that's where this is relevant. And yeah, I try to think about parts where performance of a data casting kind of Markdown logging system, where performance would matter. So it mattered with loading time. And so I think succinct data structure will help with that. Succinct data structure is kind of this magical thing. And I think the easiest way to talk about it quickly, because it's the way that I think I understand a little bit, is using the balanced parenthesis example. The idea being that if you take something like a set of balanced parentheses, which by the way is a tree, and I think it's basically it's isomorphic to a roast tree. So it might be that using trees just means, for the succinct side, and I don't know whether they're cache oblivious or not, would maybe mean just to reuse the balanced parents succinct data structure. And so how it works, the encoding of this set of parentheses in the succinct data structure is that only the significant bits of your data structure are encoded as something significant in your binary representation. So that for a set of balanced parentheses, you on the first position, it's significant that you're opening a parent, so you mark it by 1. And then you open a parent again, so you mark it by 1. But then you say, well, I decide that it's not significant when I close a parent. Okay, so you annotate it with 0. And then you have a open parents, you annotate it with 1. It's 2 open parents, so it's 1, 1, then a closed parents, and then an open parents, and you get it. And so 2 things. One is that you can generalize this encoding to even more complex data structure by using more than a binary representation. So for instance, you can encode JSON by saying, well, you just open an object thing, so I'll tag this with 1. You open You open a key, so I'll tag this with 0. You open a value, I'll tag this with 2. You open the array, I'll tag this with 4, and so on. I don't know why I used an unordered indexing system right there. Okay, so so that's the concept, and then the second benefit that you get from it is that you have a set of operations that can be done on a representation like this that end up being really fast for a whole bunch of stuff, including things like random access. So because, for instance, you can really quickly find the close parenthesis for 1, which is 10, because this is of length 10. So if you search for the closing parents for the parents that's index 1, it responds that it's the parents that's index 10. And all of these operations, like finding the closing of a context, the opening of the corresponding opening, so reversed, as well as what is enclosing me, so the direct parent, all of these things are super fast, including next sibling, first child, and all of this, and the depth at which you're at, the parent, the size of the subtree. So you have like a lot of operation that come from data structure that can be formulated in this kind of succinct representation based on two primitives that are rank and select, which are called by all of the which are like this Haskell works thing has been broken down into a whole bunch of smaller packages that implement only a subset of the functionality that are needed, and rank select is one of the key building blocks here. Okay, so and you might see how this also translates to, indeed, as we're saying with JSON, a richer data structure. It actually also works for XML, and there's an XML implementation also from Haskell Works. And you can do things like, knowing where the object closes, and so you can manipulate structured and semi-structured data pretty well, because you can keep track only of the indices that matter. You have like this kind of really tightly packed, which I guess is why it's called succinct, indices, where, let's say if you have a JSON data structure where you have a huge text blob in the middle, then it will not flip a bit. So you're able to then have a bunch of zeros and then optimize the representation so that it's more packed, so that you say something like I have, instead of having 20 0, you say, well, I have 20 zeros, and that takes you three slots instead of 20. So any fun thing you can do with transforming a sparse data structure into a dense data structure. And and apparently these structures also have good ways to deal with you sort of going in the middle and kind of finding where you are. So navigation, like the parents and the siblings, that's also good. So I want all those things for Zettelkasten, and it seems like very relevant to navigating any data structure that you want, right? It seems like zippers would, if in some sense, could be really efficient, like a comonadic zipper for a data structure, like a JSON tree of sorts, that could be that you could navigate through it, and it could be very efficient, including if you have really large semi-structured or unstructured blobs in the middle, which also sounds great, because ideally I'd like my log to include binary blobs in the middle. Why not? Like images, and maybe why not videos and sound and things like that. So, okay, so that's enough talking. Let's try and set up the project. So I think I let my thing synchronize, my computer synchronize, but I don't know whether it synchronized the repos that we're interested in. So let's go take a look. It should be in workshop, I think. Okay. Oh, shared workshop. And I think, yeah, I have structures in there. And I have, I think, HWJSON, I do. Okay, so let's start with HWJSON because I do want to open that and find out whether actually it does have, maybe it won't be sufficient. Maybe I have to download a bunch of the other HW to find out. I want to find out whether it's cache oblivious or not. I don't know whether it is or not. Let's search the Haskell work organization. Cache oblivious. Let's just even use oblivious. Should be enough. And in the organization. Nah. 5 repository for cache oblivious, and those aren't the ones we want. So I don't know whether this is cache oblivious. And so, okay, in fact, it could be that because I don't know these things very well, I am actually a little bit confused. It's very possible that, and where am I going to write this? I'm going to, yeah, this is from yesterday. And today I will want to ask a few questions. Is it maybe the case that actually succinct is for disk representation, on disk representation somehow? And that sounds wrong already. And then the cache oblivious data structure would be for in-memory data. That doesn't sound right because it seems like the cache oblivious would even work in a in the context where you actually considering your disk caches, or even your disk as a cache of your inline memory, your your main memory. So no, the answer is no. So so the fact that there's no cache oblivious, I'm sure they would advertise it. Although, to be honest, I've looked at this and it does look like it's been updated regularly though, but it didn't give me the sense. This is because of the bumping. There's some auto bumping going on there. I think that's creating some of the activity. And maybe John Kelly is also using some of those at Cardano, at IOHK. I don't know. It would be interesting to find out, I suppose. But yes. So does it matter that we don't have a cache oblivious data structure? It kind of does, right? Let's try and see whether there's all other Corla implementation for, what did I do? I think I saved where I didn't want to do anything like that. Coca-Cola, yeah. That's not what we want. Exercises, yeah. I think when I searched for this yesterday, it was really only Ed stuff. But let's look at Reddit and see whether there's been more recent stuff. Company paper. No paper, but there's code. Your comments. Shame for the audio. For the slides. Cache friendly in functional languages. GC information about the cache hierarchy, allowing you to lay. Ooh. In functional setting, you get much better bound by being cache aware. But I think at the point is, no, this whole thing can be done in a functional setting. Amortize insertion complexity here is O and log n divided by B. If you assume ephemeral access and pack the first log n levels in the block. Certified B tree, which improves on the design of the COW B tree to match this bound and doesn't set about to be cache aware, merely doesn't try to be purely functional. Think it's persistent by means similar to the COLA. Using the overmass environment approach to demortize search structure, I believe I can make this form of COLA match the insertion complexity of the original one without racing threads. Right, I think the typical imperative world solution to implement these data structures is to have a thread that kind of babysits the data structure, and whereas in a functional setting it could be done, but in this case it's done completely by the data structure itself, using laziness, I suppose, as the sort of the magic primitive. And Ed did write something in School of Haskell for that that I read, and I should probably have open. Cache oblivious, because that was quite helpful. Yeah, Bender and al, right? So it is streaming B-tree. So it is the same. Yeah, okay. So the loop is looped. That is the paper. And maybe we should take a quick look at it. See, disk access machine. I suppose they will justify the thing. Shuttle tree. Overall pointer structure to the tree. Shuttle tree layout. And then COLA. Yeah, definitely not as fast as the as a B-tree, but it's got pretty well. So I wonder, what is there a persistent B-tree? So as the data is inserted in random order for COLA is 790 times faster than the B-tree. So inserts are much faster than the B-tree, and then but searches are a little bit slower. But range queries are supposed to be fast, and I couldn't find range queries returning elements. Yeah, range queries are supposed to be fast, but so yeah, a few things is that I couldn't find anything about range queries on Ed's data structure. So I think, I mean, I'll have to read this if I want to implement anything, but I think piggybacking on, if I need to implement something on top of Ed's machinery, then maybe I will read the paper. But I think I understand Ed's machinery already, at least on the surface. But maybe if I implement, if in fact range queries are missing, but could be added with good asymptotics from this, then I suppose I might have to do that, maybe. I don't know, because succinct data structure seems like they're really good for range queries. So then I wonder whether these can you have a succinct? That's another top level question, right? Is, are there implementations of both cache oblivious and succinct data structures? Or is that a new thing? Because how would this work? Your array of keys, could that be the sort of bit array from succinct data structures? I don't know. Could the key of the map of the cache of the Cola map be a succinct index? Does this even make sense? So looking at it from this perspective, maybe it makes sense to have, so keys need like order. Actually, I was thinking that keys would need an ordering, but I think arrayed is for the storable instance, I think. You need ord k, at least for from list, and to build the map. So maybe if this is the only way to build the map, then I suppose you need ordered keys. And I think that is indeed the only way to build the map, apart from yeah, because it's, yeah, it doesn't export the constructor or the internals. Okay, well, maybe we can do some stuff just with this, which is like I think it's the basic thing, but there were some more advanced attempts, including some stuff in a branch. There's quite a lot of branches actually, including the Overmars stuff that Ed talks about here, like using the Overmars Van Leeuwen approach to amortize structures. So I don't know whether that's just only in the branch or not. There was also some issue with future work. Okay, I think I actually made some notes about this. Yeah, aim to cut the floor of a binary search. That's the main idea of dealing with the cache, that if you're accessing some neighborhood of keys often, then eventually a lot of that root, the top level of that key space, the one that's shared between a lot of keys, will end up being in the cache. Adding an offset to avoid writing to the same cache address. The binary trees of bounded balance, which is the current data.map implementation, is optimized for a non-cache memory model. B-trees are optimal for cache of known size, but cache oblivious data structure optimized, but they look like they've been designed by aliens. And they can be made updatable by using a linked list of the static structure above, which is exactly the same trick that is used, it seems, many times for doing online versions of otherwise static algorithms. I say this because I've seen something similar for the graph, the online dynamic graph, succinct graphs. Sorted monotonically. And then if we know how to merge, then we can update, because we have several static structures, and if we know how to merge them, we can merge them with intended asymptotics, then we know how much we need to pay when we grow our structures. Yeah, we pay the cost of merges when all our slots are full. And then with the persistent setting, we want to avoid paying twice, so we do the thunk, and then that's the data structure we end up with. That's the one that he talks about in his talk, and here instead of chunks, they're arrays, and then there's this M array here. I'm not sure what that's about. Yeah. And there's some recipes to go further. One would be making point searches faster with Bloom filters. I think he also mentioned this here, or at least stratified B trees. And I think there was a Bloom. Yeah, there's a Bloomed branch here, and I think does he have a fractional cascading branch? I don't think there is. But that's another way to improve things. I forget how that works. And then also parallelism by increasing the radix width, which is more consistent with Ed's later work on SIMD computations. And then prefetching, which he seemed to have somehow implemented somewhere, maybe. It's hard to tell. Okay, so I do want to play with that. There's two ways we could play with that. Let's first of all, I suppose let's open this in the same VS Code window than HWJSON, because this is oh yeah, I didn't want to open the whole workshop. I only wanted to open structures. And yeah, we'll want to put some Nix machinery here to be able to do these things from the right Haskell version. So let's go fetch some of our Nix flake stuff from one of our Haskell projects. So it could be this one, or yeah, I think that's the, oh, is that the simpler version? Yeah, that's the one that does, it doesn't do Cabalton Next, this one. So, no, this one is the Haskell.next. So, no, not that, not this. But instead, this, I believe. Yes. That's where we do Cabalton.next things, even though it's a little bit complex, we can remove a lot of that stuff, which we shouldn't need for a library with not a lot of dependencies. Okay, so let's copy that. Oh, come on, can't copy it. Okay, well, then I will create a new file. And then we shall set the compilers to be the old stuff. Right, I already made some modifications, so we should probably remove quite a bunch of those. So let's let's stack this into let's stash this somewhere into a branch. .810. I think I was trying to update it to 810. THC 810 4, I believe. So I'll just add setup and batch, and I need to do --all and structures and src. and work in progress update for GC 8.10.4. And then I'll check out master and check out setup.lhs, and that we're good. And I removed this new style because that was built for Mac. And we are, oh, we're not good because I think, oh no, we are good. Yeah, why do you write this as D? It's not D. Yeah, okay, you're updated now. And good. So 0.2, and then well, it doesn't include a Haskell version, but can we deduce which Haskell version it was from a base version of base? I think it was 8.6. That's what I'm thinking. But I'm not sure. So how will we find out? Some of the things that I had to do was remove the upper bounds to get it to work on 8.10. So I'm imagining that we will find in the last version of transformers, for instance, we'll find some good indication of what was the base needed, and then we can use that to deduce. So 0.43, and see base was less than 4.9, so it would be 4.8, and so that seems to match this. And then we say, I don't know how we say that, but we say GC, maybe we go in base, I don't know. Is that in package? It is. So 4.8, and do we know which GC version it is? We don't. GC base blah GC 7.10.3. All right, we have our version. So unfortunately, that would probably need to be built from scratch, and that's going to be unbelievably long. But hey, it's just what it is, I suppose. Create a toolkit. We don't need that. Overlays. I don't know if we're going to need that. Or it could be that it's in the Nix cache, actually. It wouldn't be in the Haskell.nix cache, but it might be in the actual Nix cache. So maybe we'll be happy. Who knows? And then these overrides. I don't think we need them. But I suppose we'll keep one just as an example. And then talk about the next, but on structures. And we need structures in our shell, and we shouldn't need any extra dependencies. Maybe I should have done this instead, and then we want those things. I mean, Haskell language server for 8. What am I doing? It's 7.10.3. I think I'm in a world where I don't want to go back to that far back in time. I think that's what happened. Yeah, the shell, blah blah blah. Yeah, I'm not even sure those things are gonna work, but we're gonna try. And then this was to, oh yeah, to get a Nix REPL. Yeah, I shouldn't need to get a Nix REPL. I should be able to just do Nix develop now. And you tell me it doesn't have a freak.nix. That's because I need to do a few things, like do this and then add freak.nix and then Nix develop. And then you're going to tell me you don't know what CUDA toolkit is, and you would be right, because we actually don't have overlays this time. All right, so you know what? I'm going to dash L because I want to know whether it's going to rebuild GHC and decide what to do from there. Oh, wow, we don't have GHC7 maybe at all in the next packages. Ooh, that's not good. That is not good, but it's very possible. How would we know? Okay, maybe I can just do index packages and GHC 7.10.3. Missing attribute GHC 7.10.3. Dropped index packages about 2 months ago. Another overlay for installing. Yeah, it is a bugger. But we could pin to another version of Nix packages. Problem still exists. Non-problem stable. Following instruction or work at all. Best to migrate. Yeah, best to migrate, but or 18.09 still includes GHC 7.10.3. Okay. So 18.09. I think that's the syntax, but I'm not completely sure. It didn't have flakes at the time, and they haven't been backported. Okay. So another problem. Flake.nix and 18 of 18. So can we? I mean, I suppose we could fork and add flakes, but yeah, let's put the whole thing. In fact, minus might just not even be picked up at all. So Nix flake 1809 right there. And that is a flake.nix. So rel a 1804 flake equal false. Hey, that's nice. Okay. So we just need to do inputs. Nix packages dot flake equal false. All right. Sort of, but yeah, I think it's just that there wasn't one at the time, and that's fine. Can leave it that. Probably the same here. Hname though I think existed, but yeah, I need packaging formats. I don't really know what that's about anyway. All right. And well, hold on. I thought I did dash L, and yet is that because that's all fetching, so it doesn't log? Or check this out. It is actually cached, so that's really good. GCC, but oh, that must be the bootstrap GC. Ah, no, this is the bootstrap GHC, so I think it's going to be at GHC 7.10 from source. Fortunately. Okay, hold on. LST transformer compat. Build with GHC 710.3. That makes sense, but following dependencies are missing. Generic deriving. Interesting. Okay. Let's see whether we can simply add that to our cabal file. And also check whether this is what we're really building. I don't even know. Because I'm hinting towards it's actually going to build GHC 710, but maybe not, maybe not. Because this thing's monad.st. Oh no, monad.st is right there. Okay, so maybe maybe we just need generic deriving. It used to be a thing that needs to be added manually. Interesting. Now I think it's just in GHC, right? And error again. Say it's missing generic deriving, but we added this, so it's not looking in here, or something else is afoot. There is this setup that LHS that's a little bit weird. I don't know whether that has anything to do with anything. Let's see if we can find any info about this. Yeah, GHC 710.3. Transformers compat. Maybe I need to override the transformers compat, but why would it not build properly? Maybe it could be something that's been fixed later. 18.09. I wonder whether that receives hotfixes or not. Yeah, transformer compat, but we need actual transformers compat is actually not in this package list, but this is, I don't know if we can think of this as something we should look at. Should probably just go to mix packages itself and check out the proper tag. Or branch or something. $18.09. Yeah, it is a tag. It's not a branch, right? I don't believe. No, it might be. Maybe we should search for 1809. Yeah, there's a rate. No, there are back fixes going to a release branch. There's also a staging branch that hasn't been updated in a while. There's one for Darwin and a small one. NixOS. is different from release. Maybe we should go for release. Same error. And I wonder where's the dependency? Could it be for something that should be pinned but isn't? Like this is building transformer compat, but where is the transformer compat dependency coming from? It's not here directly. And it's what's found is version 0.6.2. Okay, let's try and see whether we can reverse dependency in Hackage for this. Transformers. Compat. And there's quite a bit of stuff. And that's for version 0.6.2. Can we check another version? Maybe not. Only display out-of-date packages. So, what could be? Not base, not containers, not contravariant, not deepsec, not free, not GC or GC prim, generic deriving. Well, we added that, but it seems like it's done nothing for some reason. I'm not sure why, by the way. It's a bit strange, isn't it? Let's add this. Let's add the flake.mix just in case it was in fact the right solution here, because it's strange. No, it's still not. I suppose because we need to include it through a kebab package somewhere. Or it's something that, yeah, something that's not pinned is actually a pretty good potential culprit here, but at least one of the following dependencies are missing, yes. Compat. Okay, let's continue. Hashable, no. Hashable extra though. Hybrid vectors, no. Lens, lens. Between 4 and 5. And yeah, it sounds like probably lens. is a culprit here. So let's do something strange, like not put lens in there, and see whether this is actually indeed picked up by Cabal file or not. I don't think it is. It's actually compiling main, isn't it? Yes, it is. And sorry, setup.lhs. I don't know if we need that machinery. Because I suppose then also the question is, yeah, what does that get built with by default? And is this what we want? I think the whole setup thing has changed quite a lot. If I am to believe what occurred when I tried to switch to a more recent version of Cabal. Okay, so we're a bit lost in the void here. Clearly, making changes here don't change anything, so it's not clear where we can or could in the old world of Cabal 1.8 specify packages and whatnot. The packages setup.lhs, making setup. Doctier transformer compats. Is this setup.lhs here, or is this a setup.lhs that's in transformer compat 0062? Let's find out. Let's find out by going to library here. Okay, what's going on? And here, and there's a setup.lhs. And if we go to 062 and we check the Cabal file, we don't see there's a flag generic deriving, which is unfortunately default true, and apparently it still requires generic deriving, but behind these flags you might not be able to find it properly or respect the flags. But whatever it is, this is the culprit. Automatic flags was the last thing that was proposed here. So we would need to either change the flag or manually add a dependency or change the version for transformer compat, but not knowing where transformers compat is actually really being called by. Okay, what if I don't ask any of these things? Still transformer compat in that list. What if I go one Haskell before? It doesn't exist. How about version 1? It doesn't exist. How about 4? I don't think that exists either. Yeah. Okay. And so it seems like maybe we'll have to update transformer cabal to include that dependency. Okay, how about if we do p.generic deriving here? Yeah, it's going to end up being a top level dependency, so we need to override more surgically. Okay, let's fetch the next discourse. Sky Void, Sky Lake. What was his name? Haskell 2020 or something. Needs development Haskell 2020. That's the one. Skyfold. Pick the packages and overriding attributes. Packages or packages override. Yeah, I think this is it. So we bring back an overlay. Within it, that stuff. Oh, actually, we can just do it like this. It looks like. And this will be what? Transformers compat? And can we try and take 063 instead? And see whether that works. And we need to remove this. And overlay. Coagged direct missing. Aha. Right, this stuff may have been more recent. And call package might take something different. In fact, possibly the whole next language has evolved quite a bit into major versions. Oh boy. Okay, well, let's go check out. We have next packages here. We're in the release. We should be able to go to packages, development, Haskell modules. Don't know what that is. Ooh, is that the base? Is that the stuff? There are now core libraries. Is that what gets transformers compat? MTL compat, but not transformers compact. Is that part of the problem? Lens depends on generic deriving. That's right. We've established that, but we've also established a transformer compat depending on generic deriving. And everything should be pinned. Why is this not working? And that's configuration, but is that what we're looking at? I mean, this might not be what ends up in Haskell.packages. Top level Haskell packages and transformers. Let build packages.haskell. It goes from development module, at least JC 10.3, 7.10.3. BH is build packages.haskell. And compiler config is this. And where does BH, where does this come from? That's just passed along. Is it in lib? No. Build support. Miscellaneous. Yeah, I mean, it sounds like this is where it would be, right? Make package set, maybe. Generic builder, package packages. Oh, it's a big thing. Package to Nix. Initial packages. I think we have to take a look at this. And go for transformers. Compat. Those are all things depending on transformer compat. So if I go to transformer compat itself, yeah, then I get some stuff. Call package and all of that stuff. So maybe I can just replace this by this. How about that? And say 063. And you want call package. That would be lib, I suppose, maybe. Do I have lib? Packages.lib. And packages.cd lib, I would imagine. Attribute call package missing. So maybe Haskell. Maybe it's in Haskell. Call package. Where is that coming from? It's sent from above. Okay, let's say it's packages.haskell.packages then. Dot call package. Maybe .lib even. No. Okay, so we're going to need to find what gets passed to package packages, and I think that we had this in initial packages. Passed self. It passed args. Oh, it gets past call package. And call package is what? Don't know what call package is. Let's see if the discourse thing has a reference to call package. Call package. Doesn't seem like it. But we'll try with the proper search. Find this page. Call package. Yeah. Nix call. Let's say Nix Haskell call package. Aha. Well, I tried this, I'm pretty sure. Yeah. But I suppose it could be in super. It's also possible. Hey, it is. So are we going to get... Yes, we are going to get transformer compact 063, and when this is the hash we want, at least without the stuff. Actually, this is a different encoding or something. I don't know. Okay, let me try with this. See what's up. Probably won't work. Then let's try without the surrounding stuff. Okay, well, no, the shot was fine. It's just that, yeah, he still wants that generic deriving thing. And okay, well, good news is we can add it. Bad news is we don't seem to have it. Aha, it's passed. Okay. Generic deriving. Change recursion. Base preim transformers. Generic deriving. Why would that loop? Did I leave some stuff for generic deriving elsewhere? I have not. A supercall package. Okay, let's double check that we have generic deriving available in the package set. There is a question about why all the things would be passed but not this. And right, we'll need to go back to the huge list. Okay, so there is another generic deriving 110.5 as opposed to 112.2. Which one did we want, by the way? Something more than 110, which they both are. So let's see what happens when something uses generic deriving, then it just does, and that's it. Flags, can we set up flags? Compile flag. Compile build driver, configure flags. Okay, so other option, remove or specify -f generic deriving to remove the generic deriving dependency. We might want it. I think some part of the code actually do depend on it. But let's try this first. See if it gets us a little bit on the other side. Because it could be this is just bootstrapping and we won't need it afterwards. And it fails, same problem. And configure flags, do we have? Yeah, we have -f generic deriving. So let's go check again. This is the correct way to specify that flag. Flag generic deriving. Default true, manual true, -f dash generic deriving. Let's try that. This is an unsupported configuration. That's a new message. I didn't see this just earlier, but I know here it was missing for both, but now just missing for one. Oh ho. Okay, so what about fail? Fail? Not a direct dependency of transformer compat, curiously enough. So At least not of 063. But now maybe we can go back to 062, in fact. In fact, it makes a lot of sense to do so. And we fix our SHA. That's specified. That seems to be going further forward. All right, it looks like all of this work trying to struggling with the installation of projects has paid off. We were able to go back in time, use some of our Nix knowledge to override this old library with some new config flags and have things built. That's pretty good. That's better than what I've been able to do on my Mac, because on the Mac I couldn't update there are too many changes going from JC 7 to JC 8, especially in where I'm sure there would be many other things, but the immediate things I bumped into were with Fusion, I think, and Stream Fusion, and the way that it's the library sort of evolved, and it seemed to touch a lot of the code that I didn't quite understand as well. So so it will help if we're able to build this, but I suspect here this might be building. I mean, this is trying to build setup LHS, so I think maybe we do have already GHC 7.10.3 installed. I think we might, unless it's downloading all of the dependencies for that. I'm not sure quite yet. Unordered containers, would that be a valid thing from here? I suppose if you have containers. The HSpec stuff, yes, that would be needed from testing. Polypars, though, I don't know where that's coming from, but don't know these modules so well. Unordered containers here. I suppose we could have passed some flags as well to our library to not build the tests and whatnot, but actually I really want to build the tests and the benchmarks and including the different benchmarks. If it seems like they're here. That's the C++ preprocessor for Haskell. So I'm thinking we're rebuilding Haskell right now, but compiled by JC 7.10 using compiler JC 7.10.3. No, we seem to still be just compiling the main dependency. It seems like 7.10.3 was in the Nix cache. Release 1809 was in the Nix cache. So that's good. I don't want to see it, either we're getting to the point where I'm going to disconnect now, but I do want to see where the build's going to lead us. So can be a little bit patient and see that. And maybe we can take a little look at the code, right? Maybe even the tests. There are some property tests, which is pretty cool. No unit tests or some linting parameter. I don't know how that worked. Some doc test related thing for Windows. No. Wow. Crazy. What? Yeah. Holy moly. And benchmarks for inserts. Yeah, that's nice. So even a test for that overmars thingy, which comes from build O, and build O takes OMT and does O insert, and O is data vector map. So that became the main thing. Apparently, his overmars implementation became the main one. Oh, which is the one that that has chunks. So that's the one that he presented actually. So I don't know what overmars has to do with it. And also I think, I mean, yeah, maybe we should look at it again for a second here from these insert tests, because we might get to see if we track back, this might be the history of how the versions were built. First the V, the ephemeral, then the P, the persistent, then the T, the tune, but the tune doesn't exist anymore, I don't think. Yeah. And then the O, well, then the H, and the H is hash map strict. Okay, so that's a different thing, and it doesn't look like it's here anymore. Interesting. And then, well, then it compares with data.map as well, possibly. I think, yeah, this compares with data.map and data.hashmap. Oh yeah, no, this is the library data.hashmap. So of course it exists. It's just important. And so let's take a look at ephemeral and see whether that one actually has some range query of sorts. It doesn't look like it does, huh? Don't know how range queries work. Equal to those of a B-tree when it's used ephemerally. So I wonder how that works. Ephemeral. What's the main difference here? Well, okay, one has only one key and one value, and then the next map. So it's this less complexity, I think, in the numbering system. But okay, this map though holds to some, maybe that's a size, and then two array, well, an array of key and an array of values. So it doesn't do the thunk-based delayed amortization of merges. The deamortized version, I think, does it, but in a way that looks maybe more complicated, but I don't know. Does this one have any search? Well, it has the search, but not what looks like a range search. I don't think we can do like prefix search with these either, right? The keys, I think the keys are ordered and that's it. Yeah, plus in the docs, he mentions something about, where is this? Something about, I don't know, it's not in these docs, but it's in the blog post, in the School of School blog post, I think. So it's not the deamortizer article. Which one is it? It must be for the online common ancestor one. concurrent supply. Yeah. So yeah, I couldn't understand how this mapped to the cache oblivious work or the succinct work, but it felt like maybe it does somehow. So I'm going to list this as a as something to think about here. Range queries is that can the LCA can we support LCA with this? And what are we doing? We're still building. Building quick check. Okay, sounds good to me. Yeah, so this has the same numbering system approach, but there's something I don't get out of this article, which is how do you build path originally? Seems to say it's both incremental and low in memory because you only need to keep the path under consideration. But maybe there's something I don't understand about his tree encoding and how to get the path from a tree encoding fast, given a leaf of sorts. Kind of. I mean, maybe if you have access to parents, then you just rapidly can compute parents and build a path. Maybe that's the thing. Maybe that's an obvious result that you can, that any tree structure would allow to do that. Yeah, I don't know. Yeah, because what these IDs exactly mean as well seems to be somewhat related to his numbering system, which is something I don't quite understand. Yeah. Obviously, it might not be the best approach to try and understand data structure just by trying to understand what Ed Hockmet wrote about data structures, but oh well. Yeah, so cache range queries, still a bit of a mystery. Maybe that's something I should ask in the repo, since I've already asked about follow-up work. Maybe I can ask range queries. Hi there again. Been wondering about whether these fast range queries you mentioned were implemented somewhere, or if I'm overlooking something about deriving them from the lookup from the existing machinery. I might not go further in my okay. Okay. The cache and All right. So yeah, that's the case, and then we're kind of getting tired. And we're in the process of installing them, so still they're being installed. Yeah, and WC random I think is a good random number generator. Okay, so let's look quickly at the whether we can understand anything about range queries in the original paper. Range. Okay, I didn't want to do that. I don't know what I did. Okay, let's reload. Ouch. Yeah, okay. Rotate. Okay. And range. Okay, a dictionary that efficiently implements insertions and range queries. I think that's just the complexity of range queries. A large range queries returning an element. Keys are assumed to be in the range 1 to n. Lazy search BRT. Another cache-oblivious dictionary is a cache-oblivious alternative to BRT. I think these are older versions. Okay, something to someone to ban over there. And range query is turning out elements. So that, yeah, that's just the complexity. And that's older data structure, and then look at our static to dynamic transformations and fractional cascading. Look at array. So I think there must be so apparently fractional cascading is something that existed before. Okay, this is not the hit we're looking for. Disk-based storage system, range queries are likely to be faster for look-ahead array than a BRT because the data is stored contiguously in arrays, taking advantage of inter-block locality rather than scattered on blocks across disks. This is the same reason why the cache-oblivious B tree can support range queries nearly in an order of magnitude faster than a traditional B tree. Okay, I think I can see how maybe that would be the case. How would that apply here, though? You need some kind of primitive to maybe to look up a beginning and then to take on is that what search is? Do that. No, it's not. Search is something used by lookup. having lookup and then some way to walk would be, seems like that would be the way to go, but we are saying we're insane. We're insane, man. Insertion sum all. Okay, that sounds like that's traversing the whole tree, maybe. What's insert? Insert is insert all. What's insert all? Insert all takes function from A to A to T, a T, and then a vector, a non-box vector of A, and flips join F. And this returns a T. It's T. What's join? I don't know. A control monad join. Yeah. So how do you get join if you don't have monads? Is vector a monad? Probably vector is a monad. And you fold L prime. Is that some kind of traversal that I can't quite fathom that it is? I mean, this says maps, but this looks like it has nothing to do with maps. Or does it? M.insert a data vector map. But I suppose that's how you call this, data vector map. Data vector unbox, though, is not something that exists here. The data vector map is this. So the V code uses V insert, which is insert all. Insert all takes the insert and an empty map. I see. And then ends is this random vector. So you insert and then you sum all A to B and an A and a B. Using the unbox sum. vinsert and vget, which is vlookup km. So you actually pass this as A to B. Vget takes the M and waits for a key. And ends will have what is this random vector, and so you get AB just by mapping F. How is that a sum? A vector of A okay, right. Because you UMAP, so you first convert it into UBox, an unbox vector, and then you sum them in the unbox vector world. Well, I'd be curious to know what the speed of that is supposed to be. But it sounds like a lot of the work is done by the unbox vector sum, but maybe that's fine. And maybe that's a way to just test how well it fits together. That like doing a simple, even the mapping is done over the vector. I suppose because the result of vget then must be a vector then. So the result of VLOOKUP of lookup is a maybe V. It's just that we have a map of, we don't have a map of K to vectors, do we? Or is there something I completely overlooked here? It could be that randvec std is actually something different I'm expecting than what I'm expecting. This is strange. This is inserting ns, so each element of the vector via fold, and then it's using ns still to index on the get result of the gotten result. Yeah, I need to run this as a test. And lookups. The two random things and oh, look up 10K from 1 million. Build them. Okay, so that's similar than the insert all pattern, the fold out prime flip join, but with insert explicitly included here, and taking an building a million long thing from a random number generator, and oh, this is just looking 10,000 times. This is just executing this 10,000 times to have a good number. That's all. So yeah, not so interesting for us. And those are the inserts. Yeah. So no, I don't know how. This lookup is done. Oh yeah, this whole partial modal. This is also something I haven't understood, whether it was a completely different approach to do amortization calculation in these data structures, and whether that would work at all with some of these methods, or whether it's completely different. It is unclear. Let's see, we have sets here. we have member, and member is like lookup, right? Or login square. Merge though, well, merge we need to insert. Isn't that right? Yeah, here and here, and yeah, that's a thunk, and the search, but search is just something that's also used in member, I think, in this case. Yeah, here. And then heap. It's just an M array. What's an M array? I think that's a mutable array, isn't it? Unless it's, no, it's a choice of the best vector type for a given type that is as unboxed as possible. I wonder, so I tried to look at this, and I think this is part of the later work on prefetch. And yeah, it sounds interesting, but I don't know what's up. Let's see whether we can understand something by looking at the changes. Well, not at the changes, at the commits. At prefetch primitives. That might be all with the array work, and I think there's even a branch where this includes some C bits, where he does foreign function call to do some of the prefetching, which is pretty interesting, but I don't know how that works. So it sounds like, I think the arrayed thing comes from here. Yeah. And that's one of the ways in which he gets, I think, the prefetching behavior. That's sort of word length, flexible with many word length. What is GM? Generic mutable. And the data vector fusion stream. So I think these are supposed to be, I suppose, primitives in the data.vector package to build your own vector-like structures. And he does this for, I suppose, what are complex numbers here. I think complex means complex numbers, vectors of complex numbers. I don't know why it would not be called a V2, and why the fact that a vector or the complex numbers actually matters. Is there some symmetries you can exploit there? I don't know. Maybe complex is not what I think offers complex at all, but there is data.complex here. Let's look at whether data.complex is just complex numbers. Complex numbers are an algebraic type. So I suppose it's the provision of magnitude and sign that defines them. So apps, but they don't seem to be there for some reason. They must be inherited. It's just that complex is an arrayed thing, holding on to a V complex, which is what the underlying unpacked representation of sorts, boxed or unboxed based on their components. V and V complex. Don't know very much what the difference is. But that's the type family of the R for the R thingy, which in these cases is, oopsie. It has a, what's the class like? An A, which is star to star, is equal to B vector. B being just data vector. And so when we say equals U vector, what do we mean? Oh, that's the default. Yeah, okay, of course. That's the default. And so instead we can have a representation for unit that would be a U vector, but that's not a very interesting one. The double int, I suppose it's when it's really big that it starts mattering. Word 8 word 16, it's always U vector. So it's always unboxed. Maybe that's the point, is that by default it's boxed, but then when you use the arrayed thing, then boom, you get unboxed representation with prefetching, which works. I don't know how. Vector product like data types that know how to store themselves in the vector optimally, maximizing the level of unboxing provided but not guaranteed to unbox it all. Not guaranteeing to unbox it all. What's that? Not sure what that means. And prefetch R has 0, 1, 2, and I'm not sure what these are meant to be. The signature are the same, but default implementations aren't. The defaults, I mean, yeah, no, they are not. So it seems like it's just, is it what, prefetching the next thing in the memory layout? Or I don't see any indication that it's the next thing, but it could be because it's about then how it's used somewhere else, and I'm not sure whether it's actually used anywhere in this code. I think it's used in the branch. We can go check out the branch. The fetching map branch has cbits, evil cmm, and prefetch.c. So prefetch reads and writes, and I think it has the same array thing with the arrayed constructs. Oh, although, hold on, these array constructs don't have any of the prefetch blah. So maybe it's a different way to do prefetch, and maybe that stuff's been, in fact, included in the library. I have no idea. Let's look at the cbits function name and see whether we can find them elsewhere in the repo. Oh, although this doesn't work with branches, does it? It doesn't. Advanced search might work. Is there not including forks? Is it really push to? Yeah, no, you can't even search within branch. Oh, this is so bad. Where are we with our build? We're still building. Building lenses, it looks like. So let's let's play a bit and let's switch to fetching and stash and checkout. Sounds good. Just read lock not updated, cannot merge. Okay. Okay, I see. Well, let's get status now, and let's well, so you're saying you can't get stash? I think you probably can. Oh no, you can't. Flick dot lock. Okay. Get that flick dot next to, and you know what? Well, hold on. Did we change anything here? Yeah, that doesn't need to be. And let's switch to fetching, and then let's see whether, well, let's see whether prefetch area 0 does anything. It doesn't. And how about prefetch read 0? Well, only here. So I don't think any of this, I mean, we can search for prefetch as well, I suppose. She saw us the data vector prefetch. Yeah, not a delay. Yeah, so nothing there. Start of work to add prefetching. Oh, by someone else. Interesting. And prefetching machinery. Naive inserts from distinct ask list. Noise off for range. Search by message. Pattern or equal to column pattern. It's good to search for phrases. Yeah, so I think if I do prefetch, will it actually find stuff? It does. So I think if there was something where we know it, and this prefetch is probably the array prefetch, right? Yeah, it is, but I mean, unless I'm missing something obvious, I don't think this is used. Let's look at the code a little bit better. It can be used and I'm not seeing it. I wonder whether this is using my CPUs, by the way. Yeah, not so much. Yeah, that's a bit bad, but oh well. Okay, so let's go to raid and let's see whether actually there's something here that actually makes this work just by virtue of declaring something in that type class. I suppose the thing that could allow this to happen if this was hooking into vectors some way that I don't know. Let's see whether a search on package vector and prefetch brings anything. Prefetch operations. Holy moly, it is the case. Aren't a thing, at least not in JC Prim 04. What is, well, JC Prim, I suppose that's all going to depend on the JC version. Let's take a look. 04, that looks pretty old. What's the JC Prim version we use here? And is there a way to know? Let's see, JC Prim using 0400. Well, how convenient. That's the same version we're on right now. How did you know? And we were looking at which page? JC Prim, JC.prim. So if these prefetch things, okay, they call prefetch prim. Okay. So holy moly, this thing is pretty. But prefetch prim was not in the list either. Okay. But here, yes, prefetch by the way, that exists. Yes, 0, 1, 2, 3, and the name is 0, 1, or 1, 2, or 3, and is the locality level of the prefetch. Following the convention GCC and other compilers, higher locality numbers correspond to the memory being loaded in more levels of the CPU cache and being retained after initial use. You can control that? I suppose that's the whole thing. So prefetches must be a low-level CPU instruction to load the cache, to warm up the cache or something. Wow. LLVM prefetch intrinsics. Locality level N, code generated by the VM is target architecture dependent. Should agree with the GHC NCG. I don't know where the NCG is. I suppose that's the other backend. Okay. On the Spark and PPC native backend, prefetch is an OAuth. On the x86 NCG, new, what is NCG? NCG. The native code generator. Okay. N0 will generate prefetch NTA, N1 generates prefetch T2, N2 generates prefetch T1, and N2 generates prefetch T0. For streaming workloads, prefetch 0 operations are recommended. For workloads we do many reads or writes to memory location in a short period of time, prefetch 3 operations are recommended. Okay, let's look a little bit about LLVM prefetch. And almost. Fail HTML doesn't exist or isn't a directory. Is that actually when building GHC? And that fail thing, we ended up what, ignoring it or not installing it? What happened to our fail thing? Oh yeah, we're back in Nix, but we need to, we're in Nix develop though. So, wait, it does not contain flake.nix. Oh, damn it. Yes, we mutated underneath. Need to git slash pop here. And then Nix develop again. It says it doesn't have a Nix.found, but that's not true. Why are you saying that? Why are you like this? Changes to be committed. You want me to commit them? Fine. Actually, oh, right, source tree, but I thought we dealt with that before by doing flake equal false. Okay, maybe it means it's not somehow, or it can't be put in the environment, but maybe that's fine. Maybe we can keep our build now. Well, we certainly have GHC 7.10.3. Let's hope we haven't missed anything. But the fact that we can't go into our Nix develop shell, that's definitely progress. And it seems to be rebuilding stuff we've built already, but that seems to also happen. Seems like the things that are built for Bootstrap are different than the things that are then built in the shell. But that's okay-ish. It goes fairly fast. So what are we going to try then? We're going to try the HUnit test. We don't have any. The property test, well, that would be a bit long. The doc tests, maybe. Or we could try the benchmarks. Do Cabal bench maps, for instance. See if we're insane or sane. Oh, lens. Okay, that's going to take some time, I think. What is this list? It's not. Oh no, it is. Right, it's the thing that needs to be built before our project, so it should be fine. Okay, so that prefetch thing is magic, so maybe it does work actually. That's it's pretty crazy. Prefetching in LVM, report. Fetch intrinsic function, integrated language, and the proposal. Having an open source compiler, and the data prefetch module. Okay, let's look at this. Prefetch intrinsic. Okay. Blah blah blah. And so I think locality is supposed to be the thing, and the code generator to insert a prefetch instruction support. Otherwise, it is a no-op. No effect on behavior of the program, but changes performance characteristic. Address is the address to be prefetched. Attribute the specifier. If the fetch should be read for read or write. And locality is a temporal locality specifier. From 0, no locality, to 3, extremely local keeping cache. Cache type specify whether the prefetch is performed with the data or instruction cache. The attribute locality and cache type argument will be constant to integers. Does not modify the behavior of the program, cannot trap, do not produce a value. On target to produce intrinsic, the prefetch can provide hints to the processor cache for better performance. I see. So it could be that the native x86 prefetching are going to be better to understand what we're doing on our current architecture. NTA can't bypass caches, only reduce, not avoid pollution. Okay, the prefetch NTA instruction is basically used to bring the data from main memory to caches by the prefetcher, but instructions with the NT prefix are not to skip caches and avoid cache pollution. What does prefetch NTA do, which is different from prefetch instruction? Prefetch NTA can't bypass caches, only reduce, not avoid pollution. It can't break cache coherency of either the memory ordering semantic of the write-back memory region, unlike NT stores, which do fully bypass caches and are weakly ordered even on a normal WB memory. Holy moly, I don't understand half of the words in there. Wow. x86 ISAT don't specify how it implements NT-hint. NTA non-temporal data with respect to all caches level. So that's similar to what we saw in the LVM. A temporal locality, no temporal locality, right? Prefetch NTA from WB memory, WC memory. I see, those must be a write back and something else. On Intel CPU's properties, L1D normally, allowing later loads to hit in L1D normally as long as the prefetch distance is large enough that the prefetch completes, small enough that it isn't evicted again before the demand load. The correct prefetch distance depends on the system other factors and can be fairly brittle. What it does do on Intel CPU is skip non-enclosing outer caches. So on Intel before Skylake AVX512, it bypasses L2 and populates L1D plus L3. But on SKX, it also skips L3 cache entirely because it's smaller and non-inclusive. C. Do current x86 support non-temporal loads from normal memory? I'm aware of multiple questions on this topic, however I haven't seen any clear answer nor benchmark. Work with two arrays of integers. The first array A is very large, 64 megabyte. And the second array B is small to fit in L1 cache. The program iterates over A and adds its element to the corresponding elements of B in a modular sense. When the end of B is reached, the program starts from its beginning again. Measure number of L1 cache misses for different sizes of B is as follows. Measurement we made on the Z-only5 2680 V3. Hold on. Hey, we built. Amazing. More proc CPU info. Intel Xeon E5 2683. That's almost what we have. 2683. We have a slightly later version, but that's exactly the same generation. Therefore, in all the cases, B fitted into L1 cache. However, number of misses grew considerably by about 16K of B memory footprint. This may be expected since the load of both A and B causes invalidation of cache lines from the beginning of B at this point. There's absolutely no reason to keep elements of A in cache. They are only used once. I therefore run a program variant in non-temporal loads of A data. Number of misses did not change. So run a variant with non-temporal prefetching of A data, but still with the same result. My benchmark code is as follows. POSIX memo line load B into L1 cache. Well, you can specifically load B into L1 cache. So those must be intrinsics. I don't know. I wonder whether CPU vendors support or are going to support non-temporal loads, prefetching, or any other way how to label some data as not being held in cache. Right, so the streaming load, yeah, is what was in the GHC docs, which is streaming workloads prefetch 0 operations are recommended. Which mean, I wonder what that means in terms of caching. I mean, does it mean that you if it's streaming, then I suppose it means that locality matters, so you want to prefetch the thing that comes afterwards. Whereas if you do lots of random access read and write, then you want to fill in the cache based on your actual data patterns, something like that. Further reading about prefetch and associated system performance optimization, the instruction set and optimization manuals by Intel and those CPU vendors are excellent starting places, right? Intel 64 and IA32 advanced optimization reference architectures optimization reference manual, especially helpful read. Let's go take a look at that. Yeah, or not. I don't think we have AVX512 on this, do we? AVX2. AVX512, I think, is the next generation. Yeah. So AVX2. Right, so those are some of the things we've seen, MM256 and blah. Okay, so that's just an API, I think. I mean, we could check out stream. Doesn't show up. Stream, there we go. Load 256 bits of integer data from memory into DST, a non-temporal memory hint. Different latencies. Don't know what DST is. Okay. Combined volumes. Architecture programming of ML processors. Full instruction set reference. Right. So I think we want just volume 1 for now. Oh, there's a 10 volume thing. Wow. For volume 1 basic architecture. Okay, fine. Yeah, open it. DST. Temporal. Cacheability, okay, let's zoom in a bit. Cacheability control instructions. Provide control over the caching of non-temporal data when storing data from the MMX and XML registers to memory. Prefetch H does data to be prefetched to a selected cache level. As fence instruction controls instruction ordering on store operations. Oh. Load 32 or more bytes of memory for a selected level of the processor cache hierarchy. So that's, yeah, that's explicit loading into a specific level. Plus some other controls. SSC2, SSC3, streaming load, hint, non-temporal hint that can cause adjacent 16-byte items within an aligned 64-byte region to be fetched and held in a small set of temporary buffers, streaming load buffers. Subsequent streaming loads to other aligned 16-bit items in the same streaming line may be separated from the streaming load buffer and can improve throughput. Yeah, so that's what I meant earlier. It sounds like I was right. Okay. Okay, so my intuitions are not completely off, but this thing is, wow, super low level. Never got into the actual internals of a specific CPU architecture before, so that's cool. And yeah, what's also cool is that we built, and so can we do the Cabal bench map? Just bench them. How are you going to rebuild things for benchmarking? Okay, no worries. So, okay. So I think it means what I said. At least the 0 side of things, the non-locality, for some reason, means it's gonna keep the next stuff and keep moving forward, whereas with so that means non-temporal, but then temporal, I mean, I think it will do some more like LRU style optimization, meaning keeping in cache the stuff that's most used rather than the stuff that comes just afterwards. I don't know, I think so. It's weird, like locality seems a little bit weird in that sense, but prefetch blah of operation has the order of operations determined by passing around the state token. Okay, I think that must be some implementation detail. To get a pure version of these operations, use inline perform IO, which is quite safe in this context. Oh. It is important to note that while the prefetch operations will never change the answer to pure computation, they can change the memory locations resident in the CPU cache that may change the performance and timing characteristic of the application. Yes, the prefetch operations are marked has side effects equal true to reflect that these operations have side effects with respect to runtime performance characteristic as a result in code. That's a very granular, very low level view of side effects. I like it. Additionally, the prefetch value operations did not have this attribute. GHC does a float out transformation that results in a let app violation, at least with the current design. Whoa, okay. Wow, okay. Lots of words I don't understand as well right there. But that's cool. And how are we doing with A? Oh. And obviously random, do we not have the correct version? Ah, we haven't pinned that. Okay. So 0, so let's go down one level. Let's say strictly less than 0.15. How about that? And that's for one particular benchmark. And the velocity random, however, is not using the other ones, so let's give that a shot. And it looks like it's still catching 0.15. Oh. Not sure why that's the case. Maybe because it's required elsewhere. It's not. I'm a bit worried that I have to go out of Nix develop and come back in, and that it's going to take a lot of time. Because I don't trust my intuitions yet about when Nix is going to rebuild things. Or how much, how much is going to rebuild. But we could also target another benchmark. If we knew how to do that, then that would work too, I suppose. Cabal bench, and it's not that. Cabal bench. Maybe we just unfortunately maps is the one that I was kind of interested in, but let's comment it out. Still NWC random is there. Is it a dependency of some other thing? It must be. Maybe even one at random. Doesn't seem right though. Is it because I haven't added this? No. Cabal. We're using a quite new version of Cabal, but info. If I do Cabal info and there you see random, what do you tell? You say these things and you say 0.3 0.13.6.0 is installed, which must be the latest version that's compatible with the base. So why are you trying to build such late things? Because nothing is pinned, and it could be a dependency of criterion. It's probably dependency of criterion. So maybe I can limit criterion. So in that case, I would instead say, well, criterion, why don't you go below 1.1? And I need to do that elsewhere. How's that? Did not find a plan. There's no such thing as strictly less than 1.1 for criterion. Shall we say less than 1.1.4.0? We need to be specific like this, maybe. No, but why don't you give me adding a line test true to the Cabal project level. Force the solver to enable these 4 packages. Did not find a plan. Oh, right. I think that's because the plan is given by next develop. So I think I need to rebuild here. Maybe not. It could also be in statistics, I suppose. But statistics also come in from criterion. Let's look at the criterion package thing. Package and criterion. Maybe it's just that the numbering before 1.1 is different. 1.1.4.0. Then we see random more than 0.803. It sounds like the bounds are of the NWC random is pretty open, but let's see 1140. Yeah, that just says more than 0.8. Yeah, it never restricts NWC random. So we might need to specify that NWC random, as we did before, is limited, and then do the next develop thing. Would that work? No. Maybe we need to go in the flick.mix and pin NWC random the way we did here. NWC random. And that's supposed to be version 0.13.6 or similar, which indeed is the one that Cabal told us we had. So why is it not pinned? And How can we pin it? Is it because Criterion wasn't pinned? Criterion is 1410 here, which is the one that it's trying to install. Ah no, 1140. That's very different. One 510. So he's definitely trying to install an older version, so it's not picking up this package. But I think it's the difference between the bootstrap stuff and the regular Cabal stuff. So can I pick a build plan from back in the days? Can I use an index state from back in the days? Is that possible? Cabal, use old 7.10.3 index state. Cabal project, change source package in this state. This is Cabal 2.0 and index state, Unix timestamp, or some value. So, but Cabal project's not picked up by Cabal to Nix, but we don't care because we do Cabal run, so or Cabal build. So it should be picked up by that. Cabal.project, index state, and 2016. You know what? I'm fine with that. No packages, optional packages in the project Cabal. Ah, yeah, that's the minimum thing. You need a minimum package named Cabal file. Yeah, we have that. Packages dot. Is that right? Falling back to the older state, cannot benchmark the package because none of the components are able to build. Solver did not find a plan. Test true. Sure. Do that. Test true. Okay, so you didn't mean test true, you meant benchmarks true. That's right. Holy moly. And which are you picking up right now? NWC random 013. Perfect. We're going back in time. First with Nick, then with Cabal. I wonder if we can specify an index date in the flick.next. Okay, I think I went an hour and 20 minutes over already. Oh my god. Yeah, so I'm also getting cold. So I'll just stop now, and yeah, it's good progress. We almost built I mean, we built the main code, we just haven't built the benchmarks yet. So let's, I think as part of installing, we should break this in two. Install and try structures, right? Oh no, something has gone wrong. And install and try HWJSON, right? And then yeah, we're kind of on the way, but we're gonna build and run benchmarks. Okay, we have to break this down pretty deep to be able to check something, but it's not too bad. And ambiguous. Okay, and hold on, that's in actual data vector. Ooh, okay, so maybe we'll have to go back in time a little bit more. Actually, let's go and check out what the I suppose date modifies 7 years ago. Let's find something a bit more precise here. August 31st, 2015. Sounds good. August 31st, 2015. Back in time we go. And NWC random is 0.13.3 instead of 0.13.4. The obsessive nature of programmers who try to explore and maintain areas of the software engineering space. Same error. But hold on, this is actually data vector HS. I mean, there is no data vector HS, right? This is not here. Data vector storable mutable. Yeah, no, all that stuff is from the data vector, from the vector package. So the vector package is not right. Okay, so we have to assume that Ed wasn't Cabal updating. It's a reasonable assumption. Also, once the vector library was built, so it's a 0.10.2.3 as opposed to 0.10.12.3, 0.10.12.3, same version. So that's not going to help. I don't think. Let's not try to rebuild that. Let's maybe then go back then at the beginning of the project then, because he might have had the project in cache and not Cabal updated. I think that makes sense. September 9th, 2013. Well, data vector set. November. Okay, so let's go to like December 1st, 2013 or something. So length ain't good. So let's go to like February 2014. Then template Haskell ain't good. Let's go to that's I'm not sure. Scientific. No, it's base that's rejected. Huh. So our next develop infrastructure here where we bootstrapped with might not be right, but 2015 works and has vector. Hello, vector 0, 10, 13, 3 again. That's not gonna work. So it could be that 1809 is too late. We have to go back in time, also in the next expression there. Our flake dependency. Because the base stuff has changed too. Wow. Has changed. Yeah, same error. Okay, so origin defined GHT EXTS. So I suppose we need to go to some time when there wasn't an ambiguous occurrence of from mist, whatever that was. I suppose that depends on the GHC version. And maybe that's the problem. Maybe because we haven't pinned GHC and GHC prim here. That is another option. So let's write those down. Maybe here. Pin GHC prim. What else did I say? Go further back than 1809. Okay. Yes, and I suppose I will put these details. I'll put them with the context. Yeah, I think that's fine to keep there. And bring it here. Maybe more like here. All right, that's it for me. Thanks so much for watching, and I will see you in a couple of days for more software archaeology, where we try and dust off some ruins and see whether they still have magical powers. All right, take care, bye-bye.